Welcome all. Uh, as the team mentioned, I am Sudharma Mokashi. I work as a strategic cloud data engineer at Google. And today's session is for those who want to start their career in data engineering, but not sure where to start with. And Python and SQL are two, widely used technologies in data engineering domain. So we'll discuss more about this in this webinar. Yep. So, like as we discussed, we are going to discuss more on Python and SQL. But before we get started on that, let's understand what data engineering is. I hope my entire screen is visible, right? And the presentation is also visible.
Yes, it's visible.
Okay, cool. So, before deep dive into how we can start data engineering career using SQL and Python, first let's understand what is data engineering and how it is done, and the goal of it. So, data engineering is a process of extracting, transforming, and loading the data into a data warehouse or a data lake. A data engineer use variety of tools and technologies to maintain the infrastructure and the data and the processes using which they perform data engineering. uh, Coming to the goal, the primary goal of data engineers is to make data accessible for data scientists, ML engineers, and analysts. Apart from that, that data can be further utilized for building ML pipelines or AI and ML algorithms as well. Now let's understand the role of a data engineer in deep. So if we start understanding all the roles, it starts from software engineering, then it comes to data engineering, then it goes to data or business analysis, and finally there are research scientists who cover the research aspect of it. So software engineers are the ones who work more on productionalization, real-time API building, and cloud computing and automation. Data engineers are the one who take care of the data, like pre-processing of data, feature extraction of data, using different tools and technologies like Airflow, Spark, or even SQL, Python. Once they prepare that data is utilized by business analysts or scientists. They perform A/B testing, they perform product engineering, they perform dashboarding, even apply regression models on those to understand the data. And finally, neural networking architectures, algorithms, and applications are developed and published by research scientists. So they basically work on doing the research of the data. All of these, you can understand that the work of software engineer, data engineer, business analyst, and research scientist. But data engineer prepare all of these data from getting it from multiple sources, combining it into a understandable format, and then providing it to the business analysis analyst or a research scientist. Moving to the next slide. So there are a couple of approaches of performing data engineering. The first approach is ETL, which is most widely used, and the second is ELT. So first we'll discuss about ETL here. It stands for extract, transform, and load. So as the name suggests, extract is to retrieve data from various sources. When we say various sources, there are like if we take a example of mobile application or even a trading application nowadays. So it might have multiple sources like the data vendor, like the stock vendor, even the bank we consider as a vendor. So there are different vendors, and when we say vendors, it is kind of a source from where we are going to get the data. So extract is nothing but getting that data from various sources. The second step, which is followed in extract, transform, load pipeline, is to transform that data. So transformation means processing and organizing the data in such a way that it can help the further users of the data, like business analysts or research scientists or even data scientists in that case. And finally, that data is loaded into a data repository. It can be a data warehouse or can be a data lake where it will be stored. And After that, dashboarding, ML algorithm creation or pipeline creation can be taken care of. So this was ETL. Now we'll see what is ELT. So the process is somewhat same in ELT as well. So here you can see like we get the data from various sources, like, it can be a database, it can be a file, it can be a SaaS application or application events like, webhooks. Whenever an event happens, that data gets stored into the database. So all of these get extracted and loaded into a system first. A system here is or can be a data warehouse or a data lake or a database as well. Once we get that into a data warehouse, then the analysis is performed and on that particular system, and then that data will get ready for further usage. Like as we saw, like the data scientist and research scientist may able to use that data. So these are the two widely used technologies or approaches, we can say, which are used in data engineering domain. Once we get a clear idea of which approach we should follow, we'll have that clarity to utilize that particular approach in our day-to-day life as well. Working in an industry where we deal with terabytes and petabytes of data, we have to choose a specific approach before moving forward with that particular ETL or ELT process. So how we decide which approach we should take and what are the advantages of ETL over ELT or ELT over ETL? So we'll see that in this slide. So as we discussed, this is extract transform load and that is extract load transform. The only major difference in both of them is the transformation operation is performed before loading in ETL, and in ELT, the transformation operation is performed after we load the data into a data warehouse. So in ETL, it is easy to control the transformation when it happens in a separate step. When we say separate, like once we are in the mediator kind of a step where we have not loaded the data into the warehouse. So the transformation can happen in the separate step here. It is easy to troubleshoot the problems as the problems can be found in any one of these steps. Even the data is ready for analytics can be directly loaded into the target system. What we mean by this is once a transformation is done and the targeted data or and like transformed data is with us, that data only will go to the targeted system, and we don't need any of the like transformation which is happening within the data warehouse. So whatever transformations we have already completed, that's what we need in the data warehouse here. Now, when it comes to data engineering, there are again two more subparts to it. Like either it can be batch data or it can be a streaming data. What we mean by batch data is if you consider of an application which utilizes the data which is happening over a period of batch or over a period of time. Let's say we are generating set of events on a particular day, and we are consuming those events on the next day. So in this particular case, we call it as a batch data because we are not dealing with any real-time data or streaming data in this case. So whenever we want to deal with batch data, ETL approach is good, as we load that batch, extracted batch into, we extract that batch first, we transform that batch, and then we load that batch into the system. But it's not the same with ELT. So when we are going with ELT approach, there are some limitations and some advantages which we should keep in mind. So ELT, as transformation is performed in the last step, the data extraction and loading process becomes easier and faster because we are not spending any time on transformations here. Once the data is available in the data warehouse or database or any data repository, then we will perform our transformation. So the loading and extraction process becomes faster. Then there are less compute overheads and processing power required. What we mean by this is when we think about extract, transform, load, these are like general terminologies. where we say extract means extracting the data, like as we export the data in CSV, JSON, or any other format. Transformation is transforming that data, where actually we need to write a piece of code where maybe we are removing the columns, we are changing the data type of a column, or we are changing actual data as well, maybe adding a pronoun or anything to that particular data. And lastly, the load stage, where we are dumping the data into a warehouse. So here, as the transformation is happening within the data warehouse, we need less compute overheads and processing power while we are working with extract and load, because the transformation power here is it should be there in your data warehouse. The third point here is it is efficient to use for large volume of data sets. So when we say large volume of data sets, it's like it will be continuous data. Think of weather as an example. That data will keep on coming per minute, per second, or even per hour. So that data is kind of streaming data, and that data is continuous data, real-time data, which we will keep on receiving. So the volume of that data will also huge in size when we will keep on collecting that data for a longer period of time. And once we collect everything, that volume also itself is a huge volume. So this particular ELT process is suggested for streaming data, because we don't need to transform that data when it is in transit, like when we are transferring that data from source to target. And even if it is in large size, we can keep the streaming on and perform the transformation once it is available in that data warehouse. Now, before going to the next slide, all of these can be performed using SQL and Python. So if you think of any cloud, let it be AWS, Azure, or GCP, all of these clouds provides you with equipped tool stack and tech stack using which you can do this ETL or ELT. So if you want to really do all these operations by yourself, you should have basic understanding of SQL and Python to start with. If you are not very familiar with SQL and Python, also there are tools and technologies available using which no code approach can be followed, and even you can migrate or do ETL or ELT on cloud. But if you want to upskill that particular pipeline or upgrade that particular pipeline or need any customizations, you should have at least basic knowledge of SQL and Python, because these two are widely used technologies in the data engineering domain. So now like after this particular slide, we'll go deep dive into SQL and Python as well. So we'll understand what SQL is, where it is used, and we will understand it from data analytics perspective. We'll not go much into detail of what SQL is, when it was founded, and how we query and everything. We have that data as well with us, and that can be found on internet as well. But here we'll look into what are the important things which we should know about SQL and Python, so that we can start our career in data engineering very quickly. Moving on to the next slide. So for those who are new to SQL or don't know what SQL is, it stands for structured query language. So it is most commonly used database query language, using which we can access the data, manipulate the data, and even do data analytics using analytical queries as well. Again, SQL is powerful and widely used commands for accessing and performing operations, and mostly you will find it with RDBMSs, which is relational database management systems. And when you are querying a table, like when we say relational database management systems, students or people who are not from the computer background, when we say relational, it is a table. We are considering a table which is consist of rows and columns. So when we want to perform analysis on rows and columns on a relational database management system, SQL is widely used in that. And nowadays, even data warehouses supports SQL. Like you can query the data warehouse data using SQL. Even BigQuery, if you're using BigQuery, you can create ML models using SQL. So SQL, it is easy to learn, easy to use, but one should have enough knowledge of SQL and how to write queries. That will look into the upcoming slides. Okay. So SQL is, we call it as a language, but SQL is basically set of commands which we use to deal with the database. So once we have the data into the database, we can do a lot of things, right? Here are some commands which are widely used SQL commands. So we have create, create command, which is used to create a database table. Insert command, which is used to insert the data into the table. Select command used to select data from the table. Here I will take a pause, because when we say select command, select is the widely used command of, select is the only command which data scientists and data engineers use. Because when we are doing data analytics, there is very less to do with creating something new or inserting anything new into the table or updating or deleting from the table. It is mostly dealing with whatever we have, like whatever is available into that table. So analytics is performing querying and analyzing the existing database. So we will go deep dive into select and how to what are the best practices using which we should use select command, how we can do aggregation, how we can perform window functions. That all we are going to follow. But just wanted to highlight this point that select, we will be focusing on select command as it is most widely used in the data engineering domain. Then we have update command, which is used to update the rows which are existing in the table. Delete command is used to delete the rows. Alter is again a command which is used to modify the structure of the table. Like if you want to delete, remove a column from a table or change a data type of a column of a table. Or even if we want to add keys or constraints to a table. And lastly, grant and revoke are the commands which are used to provide accesses to those particular tables to respective users. So grant command is used to grant a permission to a user, and revoke is a command to revoke that permission from that user. And you can grant various permissions, like you can grant the operations which they can perform, like select, insert, update, delete. Apart from that, you can even provide them accesses to multiple tables, and you can create groups of users and then provide that access to a particular group, so that you don't want to provide separate accesses to separate groups. Okay, so this was related to the commands. Now let's look into the select query. So whatever you are seeing on the screen is just a syntax of that select query. So if you look at closely, we have select as a keyword, then we have column 1, column 2, and we can have n number of columns from that particular table. Then we have a where command, and after that we have column 1 is equals to column value. If I divide this query into multiple parts, again select is the command name, then column 1, column 2 are the columns which we want to get from a table, and after from keyword we have table name, from which table we want to fetch those columns. Now if you don't write a where condition, by default it will give you all the columns and all the data for all those columns from the table. And when you write that where clause, you are filtering out the values on the basis of your filter condition. So let's say if I put where city is equals to Mumbai, it will only give me the data from that particular table for those particular columns where city is Mumbai. So select command is very easy to understand and very easy to apply. But if we don't consider some of the best practices while writing a SQL, it becomes very challenging, and even it can decrease the performance of your system if you don't write it correctly. There are many ways to filter and aggregate the results, but window functions are the one which are like the best versions of it. Whenever you are using window functions, you can get the result faster. And as it is an aggregated function applied over a set of rows, instead of applying it on an entire table, the results are quite faster using this. Again, like commonly used window functions are row number, rank, and dense rank. We'll look into this in detail, even the output, how it provides for a particular table in upcoming slides. But this is just to highlight that window function is a method which can is a method which can be directly used in your select query to get the result faster. Yeah, here are some of the examples which we have listed for each of the type. Give me 1 second. Yeah, so here we have window functions for aggregate. We have average, max, min, sum, count. For ranking, we have row number, rank, dense rank, percent rank, entile. And to get a specific value from a particular column, we have lag, lead, first value, last value, and nth value. So when we say aggregate functions, it is to when we want to calculate sum of a particular column, like sum of, but let's say we have a salary column, or if we have any numeric column, and we want to calculate a sum of that entire column or average of that entire column, or even the min and max values from that entire column, we can use the aggregate functions. Ranking functions can be used if we want to rank a particular row compared to other rows. So row number will provide a number to that particular row according to the condition which we are giving. Rank, as its name suggests, will provide a rank. Let's say we have a results column where we have percentage, and we are using rank, then it will provide us the rank of each row according to that result. Dense rank, percent rank works similar to rank. We'll see the difference in the upcoming slides, where we'll understand like what is the exact difference between these. Lag, lead is if you want a row prior to a row, a value prior to, let's say we have a column, and if you want a value prior to that particular row, we use lag. If you want next value to that row, we use lead. First value, last value, and nth value is common. If you want a specific value from a particular table, we use first value, last value, and nth value. Yeah. Okay. So this is an example where we have 4 columns in a table, which is business entity ID, territory ID, sales year-to-date column, and last column you can see is as no column name because it is a column which is generated by a query. So on the right hand side, if you focus, we have written a query which will select the business entity ID, territory ID, sales year-to-date, whatever the sales are, and then sum of that particular column. Now we have written over. So this is the syntax of using a window function. So this will sum sales YTD column over, in bracket we are passing how we should partition this table. So we are partitioning it on the basis of territory ID. So the sum of territory 1 will fall into one particular block, sum of territory 2 will fall into one block, sum of another column will fall into another block, and so on. After that, we have stated order by business entity ID. So we have one more column as business entity ID. So we want to order that result, which is partition, using that business entity ID from this particular table, which is salesperson table, and we are ordering the entire result by territory IDs here. So if you see the result, the territory IDs which are null are listed first. Then we have 1, then we have 2, and so on. We have all the others. Why we have highlighted like 1 and 6 here? Because we just wanted to showcase the example of using order by and partition by here. So whenever we are using partition by, it will group those particular territories and do the partition calculator results. Similarly with the order by, within that partition, how we want to order is decided by the order by clause. So if you see the result, we have 1 highlighted here. The first result is lesser than second is lesser than third one, because we have ordered it by the IDs. And here also, if you see, business IDs are 280, 283, and 284. So this is the basic format which we should use to club it as a partition and perform the analytics. Now coming back to the row number. So again, like why I have put this slide in place, because this is most widely used SQL interview question as well. Like what is the difference between the row number, rank and dense rank? And in day-to-day life also, we use these three widely, and in every data warehousing project, you will see rank or dense rank or row number is being used. So what these three provides is like all of these three are ranking methods as window function suggests. So here we have the output for, if you see the third, like three columns which are to the left, where we have name, salary, and gender. And on the right, we have the output of row number, rank, and dense rank. So we have we have used salary as a main filter here, using which we have populated row number, rank, and dense rank. So row number is populated over salary, rank is populated over salary, and dense rank is populated over salary. You will see that row number is the unique one. Like it gave each row a unique value, even if the salary for Mark, John, and Pam were same. Rank will rank it according to the salary. As 8,000 was the salary for like these three, it provided the rank 1 to all. But to Sarah, it provides the rank as 4, and to Todd, it provides the rank as 5. So rank basically skips the ranks which are overlap. So if we see 1, 2, 3, so till 3, we have given the rank as 1. So it skipped all the 3 ranks and provided 4 as the 4th rank, which is something which we might not want, right? So that's why they provide dense rank as well. So the main difference between rank and dense rank is, as it was skipping the next rank here, basically dense rank provides that advantage here. Like you will see 1, 1, 1, but for Sarah it provides that the rank should be 2, and for Todd the rank should be 3. So using dense rank is beneficial when you want to calculate the exact ranks, and row number and rank are the other tools or functions which are also provided by window functions. You might have come across interviews where people might have asked question like, what is the second highest salary of a particular employee, right? Or give a particular employee who have the second highest salary. So if you use rank, you will fail. If you use row number, you will fail. If you use if you use a dense rank, then only you will get the specific output. So that's what the difference between all of these three. Now we'll move on to the best practices of writing SQL, after which we will take some questions for SQL and data engineering part, which we have already covered. So feel free to dump your questions into the Q&A section. Before going to the questions, let's understand what are the best practices of writing the SQL. So we should use consistent formatting. So for SQL, you can make use of Notepad++ or even online editors if you want, but keep that command or your query in a consistent format. Then use meaningful aliases. Aliases are the names which are provided to a particular column. So you should put meaningful aliases. Like if the column name is name, you should provide name as the alias as well. You should not put anything else apart from that. Or if you are if you are getting the first name, you should not put only name as that particular alias. You should put first name as the alias as well. So you should have meaningful aliases. Never use select star whenever you are writing analytical queries, because select star works with all the columns and not only a single column. So avoid using select star whenever you want to fetch any of the columns. Fetch those particular columns, because most of the data warehouses nowadays comes with columnar engines, which stores the data in column fashion on the blocks. So if you use select star, it will decrease the performance of those engines. use subqueries sparingly, because subqueries, again decreases the performance of your query, and subquery generates a temporary table, and that table can, again, can decrease your performance further if that subquery is pulling a lot of rows. Use appropriate join types. We have multiple join types, as inner joins, left joins, right joins, full outer joins. Whenever you need a specific join, make a appropriate use case, find and research about that join conditions and use that join type, and use comments. So in coding, we call comments which are like, which are statements explaining that part of code. So always use comments in your code, and like so whenever any other person is looking into your code, they can understand your code in more detail. So this was all about SQL. Before we move on to the Python side, do we have any questions till this point? Any questions? Okay, I think Sahil Malhotra provided real world examples. Yeah, Sahil. So, ETL is used for industries. When we say industries, let's assume an example of retail or healthcare industry, where we get a lot of patient data, a lot of pharmacy data, sales data, which should be ingested. Okay, which should be ingested directly into the table, and which is kind of a batch data. When we say batch data, it is already generated data which we want to use on the next day, or on the next interval. But in case of ELT, it should be live. Like whatever is happening should go into the database, and the transformation can happen at later point of time, as we provided the example of weather data as well. So these are the two examples of ETL and ELT. ETL is more of dealing with historical data, and ELT is dealing mostly with the real-time data or streaming data. SaaS products built on SQL. We cannot say all the software as a service products are built on top of SQL, but definitely whatever products are built, if we have we consider any software as a service product, whatever data they generate, that can be analyzed using SQL. I don't understood the exact question which David wanted to ask here, but we don't build anything on top of SQL. SQL is kind of a query language. So engines can be different, but yeah, we perform the analysis using SQL. Rahul is asking any particular tool which we can use for practice. Oh, yeah. So, all the cloud providers provide a lot of tools and mechanisms of using, their databases. They provide free tokens, free accesses, free student accesses to all the users who are students. And if you want particular tools, I will suggest, if you don't have money to spend on, use basic MySQL and Python on your local machine. You can make use of Jupyter Labs. You can start using Jupyter Labs if you want to do analysis. If we think of Python, and if you are only talking about SQL, then MySQL is enough. You can write any kind of queries on MySQL. If you want to go more into analytics, BigQuery you can try out. You can try out Redshift from AWS. You can try out Synapse from Azure. So these are kind of differences of tools which you can use. Dinesh is asking, how is window function is difference from group by query? Okay, so good question, Dinesh. Window functions and group by, as it looks similar, you actually, there are specific functions which are provided by window functions, as rank, credence rank, and row number, and even lag, lead, and other queries, which can only be used as a window function. If you want to use it as a group by, again, a piece of code should be written by yourself, and then only it can be used by group by query. And group by, again, you have to write the logic. Group by will only partition the data, but it will not analyze or aggregate like that sum and everything you have to write by your own. And even further, if you want to like make the partitions and get the data by partition in another query, you have to write complex subqueries in that case. So using window function is the task, minimizes the query writing part, and you can focus more on the outcome, what is needed. Hope we we have answered the questions. Again, like once we finish the Python part of it, again we can come back to the questions part. Moving forward. So Python. So Python nowadays people ask what is Python, why we should learn Python, and how it became like that popular, which is it's currently. So to start with, Python is a high level general purpose programming language. It is easy to learn, like it is written in a you write a English statement. That's how Python is written. It's easy to learn, easy to use. It improves your productivity, as the code minimization is there. You don't need to give braces, you don't need to follow that conventional Java kind of a methodology to write a Python code. Python code can be written in a single line, can be written of 1,000 lines. But if you compare that code with Java or any other programming language, it is much complex, much compressed than that particular codes. Like if Java is taking 100 lines of code, that code can be written in Python within 20 to 25 lines. So it is easy to learn, easy to use. Again, it improves the productivity. It is an interpreted language. Like we don't compile the code, it is directly interpreted and executed. So again, it is faster as well. It is open source, it is easily portable. One Python code can be taken from a Windows machine and can be ingested into a Linux machine without making major changes. So it's easily portable from system to system, and it supports massive libraries. So we'll go into Pandas in more detail in our session. But Python provides a lot of libraries which are useful for data engineering, which are useful for ML, which are useful for AI, and all the like data engineers you make use of PySpark as well, which is a Spark plugin or Spark library provided for Python. So it has a massive library support. Now let's discuss why it is useful or suitable for data engineer. So when we think of data engineering, there are various data formats, various data types when we deal with various set of sources. So we can have CSV files, we can have TSV files, we can have JSONs, text data, unstructured data, even JSONs. So when we think of all of these data types, Python works the best with all of these types. And it provides all of these types using built-in libraries as well. Like JSON, we have a library in Python, which is inbuilt library. CSV is a library which we can directly use to analyze CSV data. So, it works with all the formats very fluently. Again, like a data engineer basically fetches the data from a source. So when we fetch anything from a software source, we write APIs or we use APIs which are already there to retrieve that data. Whatever data we are getting from that API, we get it usually we get it in a JSON format. And Python has a library named JSON to handle such type of data. So again, it is easy to deal with the API data as well with the use of built-in libraries. And we not only obtain the data from different sources, we also process it. So most popular data process engine is Apache PySpark, which comes with Python data frames and even offers an API. If you think about a very large scale database or data set, we should go with PySpark. If we are thinking of a 100 GB, 200 GB of data size, we should go with Pandas here. So Python provides support to both of these. So again, that's where it is suitable for data engineers. And lastly, apart from this, as data engineers, we should spend minimal and still quality time on writing our code. We should focus more time on understanding the sources, how the data is looking like, how we should process it, and writing our algorithms, processes, and everything. So we should spend less time in actually processing that data or writing the logic for processing that data. And again, Python is something which can which can be used to save that additional time of coding and use the existing libraries or existing Python functionalities to do that task. Coming to like the libraries which are widely used by data engineers, Pandas and PySpark are used for data analytics. Pandas is a library which is widely used for manipulation and analysis. It provides like easy to use data structures for data analytics. Pandas basically provides you a functionality where you can add your data. Maybe it can be CSV, it can be TSP data or anything to a table-like format, which we call as a data frame. It is a two-dimensional data, which is rows and columns. And as you do your analysis in SQL, similar kind of analysis can be performed using Pandas with functionality which it provides, like select, create, insert, update, delete, whatever functionalities we have seen in SQL. Same can be performed using Python using Pandas library. It also provides tools for data cleaning, transformation, and analysis. Like if you want to do data aggregation, time series analysis, or even if you want to put missing values in case if you have missing data, then also Pandas will be a good option to consider here. And when you have a data size of more than 300 GB or 400 GB, go ahead with Spark. Even if you are dealing with real-time data, go ahead with Spark. So Spark gives a library called as PySpark, where you can make use of Apache Spark functionality, which is a distributed data processing platform, and use their their functionalities, PySpark functionalities, to do the data analysis. Here is a sample code which I wanted to provide a glimpse of, as we were just going to discuss on the basics and the best practices of these. So this is a Python code which is using Pandas library to create a data frame and to put that data, put some data into that data frame. So if you see the first line, it is an import statement using which we are importing Pandas library into our code. Then you can see pd.dataframe. Using that, we are creating a data frame. So we have specified the first data frame as 1 and the second data frame as 2. We are having 3 columns: name, subject ID, and marks code. And we are assigning that data as well. Like name, we are assigning a list of data. And again, subject IDs, we are assigning list of data, and marks code, we are assigning list of data. We are also provide an index to each of the rows so that that particular fetching becomes faster again. Secondly, also we have name, subject ID, and marks code, and we are assigning an index to that particular data frame. Now these are 2 different data frames. But let's say if we want to get that output into a single data frame, we use pd.concat. And using this, we get this output, we are concatenating these 2 data frames and getting that output as a table. So here, if you see on the left hand side, we are getting the index. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So there are 2 different indexes for these 2 different data frames. So that we are getting on the left hand side. After that, we are getting names of all the names which we have assigned into the data frame. Then the subject ID, and then the numbers code, marks code into the last column. After this, there are multiple functionalities using which you can perform a lot of operations on these 2 data frames. Like we have performed concat operation, you can perform joins, you can perform filter operations, you can perform group by operations. All of these can be performed on Pandas in parallel as well. And if you're dealing something with the time series analysis, so that can also be performed in Python, and even you can plot graphs. There are a variety of libraries are available on like matplotlib, and even there are a lot of libraries which are available to perform the analysis as well as to plot some graphs as well along with this. So I guess that's what I had for today. We had only 1 hour, so I covered most of the basic parts which one should know to become a data engineer using Python and SQL, and some of the key concepts, which you should understand and learn by your own as well when you are dealing with Python and SQL. Maybe in some upcoming sessions, we can cover more detailed session on data warehousing, or even Python or SQL if we want to go deep dive into Pandas or PySpark or anything of that sort. But I hope you learned something new about data engineering. You got some understanding of Python, SQL, ETL, ELT, and all. So I guess that's it from my end. Any questions again? If I miss any of the question, let me go back to the question. Yeah. So here, Sahil is asking, can you give an example of some work you do as a data engineer at Google? Yep, sure, Sahil. So at Google, we work into different verticals. I will, give you an anonymized example of a client on which we were working we were working in healthcare industry into analyzing their, sales and activity data. So if I provide an example to you, in healthcare industry, basically MRs or sales reps, they, go to clients and advertise their product. And then when I say client, they go to doctors and provide their medicines information to them and ask them to prescribe those medicines to the patients who visit them. And after that, the flow is like patient will go to the doctor, doctor will prescribe the medicine, they will buy it from a pharmacy, and then there is a sales data which is generated. So basically we were asked to help the client in building those pipelines where we can get that data from the pharmacy, we can get that data from the physicians center, we can get that data from from the medicine warehouse, and even we should get that data from all the other sources which are possible. And then we have to provide an report to the pharma company that how many products which the MR marketed to that particular doctor were actually converted into a cell as well. So this is just one example of healthcare industry, but we work with clients to help them better understand their need. In this case, they wanted to analyze how many customers are getting converted if they are marketing, if they are marketing some of the drugs to some of the medicines to the like physicians or doctors. In other cases, it is similar. Like if anybody want to improve their business, they have to have a data engineering field or data engineering vertical within their company. Then and then only they will going to understand that how their process is running, what is not working, what is working, and then they would be able to solve the real problem. So here also we help them in doing the analysis. We provided them with some data pipelines which were created in Google Cloud using BigQuery, Dataflow, and Dataproc. And using another tools, we help them in, we use some tools to create dashboards and show that data in a visual format as well. After which, they use that data and they modified some of their processes to maximize the output and to get oh, you also used to work at CS. Okay. So okay, if you want some other example, we do have example related to electricity industry where some of the largest electricity provider of US wanted to do a data analysis of their field. So this was kind of a real-time example where they were having drones and cameras set up in all the places of their site. And they that those drones and cameras were picturing images, videos, and sending it to the cloud with some automated processes. What we were doing is we were we had written some pipelines to analyze those images in a live what we can say, like we call it as real-time data analysis. But what we were doing there is we were analyzing the images using machine learning algorithms, and we were taking some actions immediately if there is any emergency situation in that particular area, like if a transformer is having like caught a fire, or even if a pole is not in a right direction, and something like that. So as you know, the healthcare example, this was kind of an example which we were working with electricity provider of US, where we were helping them to do some real-time analysis and avoid emergency situations in that case. I guess hope that help. Okay, Daniel is asking, how do you create a pipeline to collect the data into one leg for usage? Explain the narrative using Python. Okay, so when we say pipeline, it is set of steps which we use. So if you think of a source, right now I explained the electricity example, right? So the source is that particular field which we have. From there, the cameras were the equipments which were catching those images and sending it to the cloud. So the code which is written, like which is needed to send those images from that camera to the cloud, there Python can be used. Okay, so on that particular machine which is capturing the images, or even the drone, can have a Wi-Fi accessible can have a Wi-Fi as a networking device, and that like that drone was sending those images to the cloud using Python. So the code was written in Python, which was taking care of sending those images. Once it lands into the cloud, then again we want to use some APIs to find out if there is any fire or any any other thing which or if the pole has cracked or anything. We have to find that using some APIs or some models, right? For that, again, using that API, we have to use some programming language. So there also Python can be used. And again, when you are pushing some notifications at the like if that image have any emergency situation or not, there also Python can be used. So Python can be used throughout. And once the metadata of this will be stored into a data warehouse. So let's say it we got 10 images. On all the 10 images were not having any of the emergency situation identified. So this will stored as a row into a database, like the metadata of the processes which we follow. So in future, if somebody want to do analysis on, okay, we have this process, but like if this process is useful or not, or in the past few weeks, past few days, past few months, how many failures happened, and how many failures we were able to catch. So that's where SQL can be used. So Python can be used to write the process and collect the blocks, and SQL can be used to do the analysis for that. I hope that answers your question, Nandini. Okay, Aditya Mishra is asking, can you please give a real life example of portability? Like how is Python portable? Okay. So let's say if you are writing a code in Python and you are doing data engineering, and you are doing some data analysis on a particular platform. Let's say you are doing an analysis on a CSV file. So the code which is required to read that CSV file, then get those rows into a Pandas data frame and perform the analysis would be constant across the platforms. Like it is it's not like if you're doing that on Windows, that code will change, and not that like if you're doing that code on some other platform like Linux, Mac, or anything else, that code will change. But in some other programming languages, the code might change because some of the libraries or some of the functionalities are not not the same across the platforms. I hope like I don't know who asked the question, but I hope that answered your question, Aditya. I hope that answered your question. PySpark is a Python API for Apache Spark. Yes, I have never received recording or material shared for okay, that's not my turn. It's okay. I think we covered. Okay, I want to know about the GeoPanda. Can you please tell me about Can you please? Okay, I'm not able to see the question slides properly. Somebody was asking about, yeah. So I got your question. So if you want to know more about GeoPanda is basically geospatial data analysis. So when we want to do some analysis on maps data, coordinates data, or even soil or ground data, basically, or let's keep it simple, coordinates data. If you want to analyze, that's where GeoPanda helps. It's more of geospatial analysis. So it's more on that side. Okay, I guess questions all we have covered. Do we have anything in the chat? Okay, I guess we have covered all the questions.